What if I told you there's a single type of bacteria that could threaten our food supply, cause years of crippling sickness in people, and jump silently from animals to humans? Well, today we're putting on our detective hats to investigate exactly that, a widespread and incredibly resilient disease called brucellosis.
All right, so here's our game plan. First, we're going to identify our culprit. Then, we'll examine the impact it has on animals, understand the threat it poses to us humans, look at the forensic tools used to track it down, and finally, explore our strategies for fighting back.
You know, every good investigation starts with profiling the suspect. So, let's get right into it. So, what exactly are we dealing with when we talk about brucellosis?
Okay, at its core, brucellosis is the name for infections caused by bacteria from the Brucella family. But here's the absolute key takeaway, the thing you have to remember. It's zoonotic, and that's just a scientific way of saying it jumps the species barrier from animals to people. This makes it a double threat, hitting both our agriculture and our public health.
Now, Brucella isn't just one single bad guy. Think of it more like a crime family where each member has its preferred target. For example, you've got B. abortus. That one mostly goes after cattle. Then there's B. melitensis, which is a huge deal because it's the one that most often infects humans, and its primary targets are sheep and goats. You've even got others, like B. suis, which infects pigs and wild animals like reindeer.
So we've identified our suspects. Now, let's head to the primary crime scene and see exactly how they operate in their animal hosts.
Let's start with cattle, where the main agent is B. abortus. For a farmer, an outbreak of this is absolutely devastating, and it's mainly because of how it attacks an animal's ability to reproduce.
The classic, heartbreaking sign of brucellosis in a herd is a late-term abortion, often called a contagious abortion. But the damage doesn't stop there. It can cause infertility, swollen joints, and a drop in milk production. And here's what makes it so contagious. The infected animals shed unbelievable amounts of bacteria in birth fluids and in their milk, which can then spread through the whole herd like wildfire.
And it's a tragically similar story when you look at other important livestock. Across all these different species, the bacteria has a clear MO, a method of operation. It loves to colonize the reproductive organs. This is what leads directly to those abortions and fertility problems. The infected animals then become these massive shedders of bacteria, creating a huge risk of transmission, not just to other animals, but to people too.
So, we've clearly seen the serious economic hit this has on livestock. But what happens when this disease makes the jump? This is the point where a serious animal health issue becomes a major public health crisis. So how does this jump happen? Well, there are a few key routes. For most people, the biggest risk is actually consuming unpasteurized dairy products. You know, things like raw milk or fresh, unaged cheese from an infected animal. For people who work with animals, farmers, vets, hunters, direct contact with infected tissues is the main danger. And, believe it or not, in places like labs, the bacteria can actually get into the air and be inhaled. It's a serious occupational hazard. In humans, the disease is sometimes called undulant fever, and that's because of its telltale symptom, a fever that rises and falls in waves, over and over. At first, it can feel just like a really bad flu, but if it's not treated right, it can turn into a chronic, debilitating illness with long-term complications affecting your joints, your heart, and even your nervous system. And that risk of just breathing it in, it's especially real for people working with this bacteria in a lab setting. In fact, and this is wild, brucellosis is the single most commonly reported bacterial infection that people catch while working in a laboratory. And that just shows you how infectious this thing is and why it has to be handled under super strict safety conditions. So with such a serious threat, how do vets and public health officials actually figure out if an animal or a person is infected? Well, their forensic toolkit basically has two main approaches.
The first way is to catch the culprit red-handed. This is the gold standard. It involves taking a sample, like tissue or milk, and actually growing the Brucella bacteria from it in the lab. The other method is to look for the footprints the infection leaves behind. That means detecting the antibodies that the body's immune system creates to fight it. These tests, called serology, might not be as definitive, but they are fantastic for screening large herds of animals really quickly.
All right, we've seen the problem. Now let's talk about the solution. How do we fight back and control the spread of brucellosis?
Our main defensive weapon is vaccination, using something called a live attenuated vaccine. Now, what does that mean? Well, it's pretty clever. Scientists take the real dangerous Brucella bacteria and they essentially weaken it in the lab so it can't cause disease anymore. When this weakened version is injected, it's just strong enough to teach the animal's immune system how to recognize and destroy the real pathogen if it ever shows up. The workhorses here are the S19 strain for cattle and the Rev 1 strain for sheep and goats.
And check this out. This chart shows you the vaccine in action, and it's brilliant. We're looking at the percentage of Brucella bacteria that get killed by blood serum from vaccinated sheep. Look at day 0, before the vaccine is really kicked in. The immune system can only take out about 15% of the bacteria. Now fast forward 30 days. That same animal serum can now kill over 35% of the bacteria. That is more than double the killing power, clear proof that the vaccine is doing its job and training that immune system.
But, and this is a really big but, these powerful vaccines are not a perfect solution. They have some major drawbacks. First, because they are still a live bacteria, they can accidentally infect the vet or farmer who's giving the shot. Second, if you give one to an animal that's already pregnant, it can cause an abortion. And third, and this is a huge headache for control programs, they can make a vaccinated animal test positive on those antibody tests, which makes it really hard to tell if an animal is vaccinated or if it's truly infected.
And all this brings us to our final question. Many developed countries have actually done it. They've successfully eradicated brucellosis from their livestock from their decades of tough programs. They won their local battles. But with the bacteria still rampant in many parts of the world and hiding out in wild animal populations that don't care about borders, the global war is far from over. Which leaves us wondering, can a disease this resilient, this ancient, and this widespread ever truly be defeated? Or is this a fight we're just going to be fighting forever?